Hello everyone, welcome to my channel CSC Core Concepts. Today we are going to discuss about arrays. To begin with, let us understand a problem so that we can make out why do we require an array. Let's say I want to store the marks of one student. The solution is that I can declare a variable in any programming language of some data type like integer, as I discussed in my previous video where I discussed about introduction of data structure. So there are primitive data types which are given by the programming languages. So based on that, I am declaring a variable called marks as integer type and I'm assigning some value, let's say 10. Or I can scan the value from the user. Now, if I am given a problem to store the marks of 5 students, or let's say I want to store the temperature of 10 days, then if I declare 10 or 20 such variables, then it is quite challenging because the manipulation and maintenance of the data is difficult, and it is very difficult to keep track of all the data, declare all the data, all the variables. So for the solution to this problem is arrays. So basically what are arrays? They are the data items which are stored together in one variable and in a contiguous memory location. By contiguous memory location, I mean that in a proper, in a one next to next memory location. They are not scattered and stored. So it is a way you can say a static allocation manner. An array is basically a finite collection of similar items. Similar means that if I am storing the marks, then all the values of the array will store the marks. You cannot store one record marks, second record as the age of the student, like that. You cannot store. So all similar elements have to be stored, and the number of elements in the array is finite. You cannot have an array which is of infinite size. So in a way I can say array is the simplest type of a linear data structure. So by linear we mean a sequential data structure. So arrays can be classified as one-dimensional array, two-dimensional, and if the number of dimensions or the number of variables are more than two, we call it as a multi-dimensional arrays. So let us have a look on one-dimensional arrays in detail. So you can say again, one-dimensional array is the simplest form of the linear array where we are declaring a variable, let's say array A of size n. So they are represented within square brackets, and n is the maximum size or the maximum number of elements that array can contain. And the elements are referred as a of 0, a of 1 and so on till an minus 1 because the index is starting from 0. So if I want to declare marks of 5 students, I will declare a variable called marks of size 5. So it indicates that it is an array and I can explicitly assign the value, or I can scan it from the user. Similarly, a variable called sales. So I am storing the sales value for 3 days and the sales amount is in terms of floating. So I have declared the array as float. So if I want to store the marks, how does it store? First, on the top of the first row indicates the actual memory allocation address. Now, actually the address is in the hexadecimal form. Just for the convenience of showing, I am just telling you the location, so that I can highlight that the location is contiguous. It cannot be that the one element is stored in one location, another in some other location. The second row indicates the value of the array and the third row indicates the index. Index means array of 0. At 0th position the value is 25, at first position it is 34 and so on. Here 0 is called as the lower bound of the array, that is from where the index is starting from, and 4 is the upper bound of the array, and so I can refer to each of these values as marks of 0 if I am referring, that is the first element, marks of 1 is the second element and so on. So if I want to compute the length of the array, the formula says upper bound minus lower bound plus 1. So my upper bound here is 4, lower bound is 0, plus 1 is 5. So the length of my array is 5. So if my lower bound is 1, that is if I am starting the array index from 1, then the length will be equals to upper bound. That means here if I have started the index from 1 till 5, then the length of the array would have been 5. Now, if I want to store strings instead of numbers, cannot I store? Yes, I can store where using string, that is an array of characters. The difference between a numeric array and a string array, character array, is that character array is always terminated by a null character. So for example, if I want to store Ram, R is one value, A is another, and third is M is the third value. So I am declaring a variable called name of type char and size 4. Why am I declaring size 4? Because R is the first position, A second, M is third, and the null character is the fourth, which indicates that the string is terminated. So have a look on the operations we can perform in an array. So we can always traverse through an array. Suppose if I have a marks of 100 students, I can always go through the elements of the array, or I can count. Suppose I want to count how many students are getting more than 80. So I can always traverse through the array, means travel through the array, and I can pick out those values getting more than 80 and I can sum them up. Second operation which I can perform is insertion. So I can always insert elements into the array in the collection. And the third operation is deletion, where I want to remove some existing records from the array. That is also possible. And searching. If I want to search for a particular value in the array, that is also possible. So these are the four basic type of operations which can be performed on any array. So if I want to insert, the element, any new element in an array. So if the array is already existing, I have declared the array. I have stored some of the values in the array. So I have to be careful that the array has to be little bigger in size so that there is space to be inserted. So if there is no space here to be inserted, then I cannot insert any element. So here you can see that the last position is vacant. So if I want to insert at the end, simply I have to insert. Nothing else I need to do. But assume that I want to insert an element in the middle of the array. Let's say at the third position I want to insert. So what I have to do is that after the elements 429, that is 135 and 87, have to be shifted by one position to the right so that I can create a space at the third position where I can insert the element. Similarly, in case of deletion, if I want to delete the last element of the array, simply I will remove it from that position. But if I want to remove any value from the middle of the array, then in that case, I have to remove one other value which I want to and shift one positions on the left hand side, because I cannot keep any position blank in the middle of the array. It has to be contiguous. Now, the question is that when the array is stored in the contiguous memory location in the contiguous memory, then if I want to retrieve the address of any particular element from an array, how can I? Let us consider a problem that a person wants to keep the record of the number of packets of milk sold for 5 days. So how can I store? The simplest data structure I will use, that is the array. So I have one dimensional array. So the first element, number of packets sold on the first day is 247, second day is 56, and so on I have stored. Okay, for 5 days. So this is my array, how it looks like. Now suppose if I have, take another example, say I want to store the sales value or the profit amount from the year 1932 to 1984. Now here if I start the index from 0, then how would I know which year is relevant to 1980 or 84? Then rather than starting the index always from 0, I can start here the index from 1932. so that it will be easier for me to understand that at index position 1932, whatever is the value, that is the profit value for that year, right? So if I am starting my index from 1932 till 1984, then how will I find out the length of the array? So the length of the array can be determined as upper bound minus lower bound plus 1. So 1984 minus 1932 plus 1, that gives me 53. So I am storing the profit value for 53 years. Okay, so this is my index 1932, 33, 34, so on till 1984, and the profit value is for each year is being associated. So since it is stored in a contiguous location, we need to keep a track of the memory location. Do we need the hardware location? We do not. But let's say even only the first memory location is enough. But anyway, if I want to find out the memory location of some other position of element in the array, how will I? So the first location of the element is called as the base address. So using this base address, I can reach to any location of the array. So the formula is location of the array at kth position, any position, is equal to the base address of that array A plus W into k minus lower bound, where W is the number of words per memory cell. You can declare one byte as one word, or generally it is 2 bytes is one word. Okay. Say if I have an array profit and the base address is 200, means the array profit is starting from base address 200, and each element is stored using 4 words. So the base address, the first element for 1932 will be stored at 200, 1933 will be stored at after 4 positions, because each element is requiring 4 words. So 204, then 208, and so on. So now let's say if I want to find out the memory location where 1965 is stored. So how will I do? Base of that array, that is 200 plus 4. 4 is the number of words used by one location. 1965 is one which I want to find out, minus 1932. Okay, 1932 is what? It is the lower bound. So if I solve this problem, I am getting 332. That means at 332 position, my value for the year 1965 is stored. So using this formula, you can retrieve for the memory location of any element of the array. So that's all for now. In my next video, we are going to discuss about two-dimensional arrays and multidimensional arrays. So for more such informative videos, please like, share and subscribe to my channel CSE Core Concepts. Thank you.